Hello, and welcome back to ATARC's webinar series. Today, topic experts will share strategies that agencies can implement to alleviate the concern of the unknown and make operations more efficient. My name is Kirsten Kotsaruba, and I'll be moderating today's panel discussion. ATARC stands for the Advanced Technology Academic Research Center, and ATARC is an organization that facilitates collaboration between government, industry, and academia in order to accelerate technology modernization initiatives. ATARC provides ongoing opportunities for cross-agency collaboration through on-site interaction, learning, and market research. I would like to welcome all of our attendees who are joining us right now, and a special thanks to Lisa Ragusa-Fidala and the entire Aqua Security team. This afternoon on the agenda, we are going to hear from each of our panelists. We will have time for some Q&A, and we're going to pop in a few poll questions. So that being said, don't forget to submit questions and comments of your own in the Q&A section. We love for these webinars to be as interactive as possible. And be sure to answer the poll questions in order to receive your CPE credit for attending today's event. So with that all said, I'd like to welcome our panelists. Come on camera, looks like they're all here. And we're going to begin with a quick round of introductions from each of you. So who are you? What's your role and the agency or organization that you work at? All right, let's start with Martin, please.
Hi, everyone. Kirsten, thanks again for having me on one of these. So I'm Martin Stanley. I'm the Emerging Technology Branch Chief at CISA, and I'm currently on detail to NIST, where I'm working on the Trustworthy and Responsible AI program. So looking forward to chatting with you today.
Thank you. And Philip, let's go to you next.
Yeah, hi everyone. Phil Pearson, I'm from Aqua Security. I'm Aqua's field CISO. I've been developing zero trust frameworks since around 2017, mostly in the private sector, but some public as well. Also noteworthy that I work part-time on the implementation content from the CSA. Today, I'm eager to share my lessons and insights on how Zero Trust offers practical solutions for protecting your modern applications, obviously today with a specific focus on public sector.
Thank you. Trevor, would you like to go next?
Certainly. Hi all. My name is Trevor Bryant. I'm the System Security Officer for the .gov top-level domain or TLD program over here at CISA. I'm really excited today about this topic because I was fortunate to be on some of the very first teams, early experience and adopter with container technologies in the government. And in my personal professional capacity, I actually co-organized the DevOps DC meetup and the DevOps Days annual DC conference, where we invited our government to come and learn about the type of technologies we're going to talk about today and share their own adoption stories. And here in my professional capacity, I had contributing language to the DoD DevSecOps reference guide, the Defense Security Cybersecurity Authorization Working Group, or DSOG as was commonly acronymed as, and where I co-authored the continuous ATO papers. And again, about this particular technology and this topic, I'm really excited to be here.
Fantastic, thank you. Let's go to Adam next.
Thank you, Kirsten. Good afternoon, everyone. My name is Adam Cologne, and I work at TSA as a senior cybersecurity specialist. What I do here with TSA a lot of times is focused on the operational technology, the technology that actually at the checkpoints. But we're also doing a lot with our development life cycles. We're building on the environments, and so we're getting more into a container. We're trying to figure out how we can containerize things and building out our zero trust framework internally. TSA actually recently had a zero trust day to try and provide more information to our people here in TSA, explain what we're doing, kind of set the framework and the pathway on how we're going to ultimately get to our final goals. So I'm really excited to be here today, kind of talk more about how we're starting to implement our containerization process.
Fantastic, thank you. And Edmund, let's hear from you.
Good afternoon, folks. Edmund Kuchel, Naval Information Officer Center Atlantic. I am a software developer in heart. I've done DevSecOps for quite a while right now. I am detailed to the Department of Navy Chief Information Officer, as well as the OpNav and 216 in all things related to DevSecOps cybersecurity. I'm also the process owner for the Rapid Assess rapid assess and incorporate software engineering, the RAISE process for leveraging containerized applications, to take a more drastic approach on how we authorize those containerized applications into an operational environment, as well as I was developing the Zero Trust implementation guide, helping the Department of Navy and the DoD ZPFMO reviewing for all of the programs and the DoD components on their ZTA implementation plans. Over to you.
Thank you so much. So jumping right into our first question, Trevor, I'd love if you could kind of lead us on this first one here just to start off. But I want to talk about what strategies should be employed to secure containerized applications from runtime threats, while also adhering to the Zero Trust model, especially in dynamic and scalable cloud environments.
Sure. In previous roles, I was actually on the infrastructure and platforms team as a provider of capabilities and technologies. But if you don't mind, I'd like to kind of flip it around to where today in my capacity, I'm actually an application owner. So it's the very first time where I actually get to be a potential customer of Zero Trust optimal environments. And so I'd like to offer my perspective on that, of what the value is and some of the strategies I'd like to see as a customer. So of course, the model is going to differ across organizations, but or it's going to be similar across organizations, but the implementation may differ. We want to design these environments to be hyperscaled architectures, while also emphasizing the importance of our general basics these days: authentication, encryption, microsegmentation, and continuous monitoring. And I think part of these elements to an overall strategy can help with our creation of our system security plans at a much more expedited rate for continuous authorizations, and all while delivering actual value to what the business or mission objectives are, excuse me. And from my customer perspective, while I don't typically see environments having or sort of a common shared infrastructure, organizations will typically have multiple cloud account organizations and generally lots of virtual machines that aren't necessarily leveraging the cloud models or the cloud characteristics. I like to remind us all that cloud computing technologies can be multi-public, private, or hybrid. And while meeting these specific characteristics, it's actually the type of technology it is that makes it cloud computing and not necessarily where it lives. So as part of some of our strategies, I would like to see a lot more of these reminders, sort of the user or customer-centered experience of, am I going to be part of a Zero Trust optimal environment? So a little bit of a flip side, but I wanted to share that perspective there.
Yeah, thank you. I appreciate that. And based on what Trevor just shared, would any of our other panelists kind of like to weigh in on how they would respond to the same question as well? You can just jump off mute if you feel like sharing your thoughts. Martin, you look like you want to share some thoughts.
Okay, sure. So first of all, I think that was a great initial answer. And I think one of the things that I'm here for is to talk to the Zero Trust community about the fact that CISA feels very strongly and has really jumped behind the administration priority on secure by design. And I think we believe that Zero Trust is really integral in establishing and maintaining these environments. And in particular, the project that I'm currently working on, which is trustworthy and responsible use of artificial intelligence in the federal government, in particular, these infrastructures that we're going to be building our AI systems on top of require Zero Trust model. They're going to leverage all those controls in order to assure these services and help to protect against some of the risks, not all, but some of the risks that are going to be taken in order to realize the benefits of artificial intelligence. So hopefully we'll talk a little bit about that. But again, I think understanding just this pervasive nature of these practices and how far and wide they reach as far as their potential impact is really important for the community to understand, I think.
Thank you, Martin. And we have time for one more panelist comment before we move on to our next. Philip, do you want to weigh in?
Yeah. So there's a couple of things. I think as a CISO, when you're building these environments, I think you have to be able to answer a number of questions. For me, the first question is, are my workloads and resources free from vulnerabilities? Are they free from misconfigurations? And can I defend against a live attack in production? And I think if you can answer in the positives to all of those three questions, then you're on your way to zero trust. They're fairly simple questions, but very complicated and difficult to answer in the positive. And that's where the frameworks come in. So the frameworks are where we can start to piece this together. And again, I think great answers so far, but really interested specifically in the dynamic side, the automation, the ability or everybody's ability to create baselines in which they can build on and enforce policy. I think that's really key. The ability to be able to enforce a policy is true security, right? If you're not enforcing, then it's just simply information. It's not security. That's my opinion.
Thank you. Thank you for sharing that. Anyone else, or should we move on to our next question in our set? Okay, great. Well, with that said, Philip, you're actually the person that I wanted to start with on this next question first, which is considering the principle of least privilege in zero trust architectures, how can agencies implement effective access controls and segmentation for containerized workloads to minimize the attack surface?
That's actually a follow-on, really, from what I just mentioned. So I talked there about policy and policy enforcement. I think most of what we're talking about is the cloud, or at the very least digital. So in this space, everything is in code, right? And if it's in code, then it stands to reason that you should be able to defend in code. And the way to do that is through policies. So policy enforcement, I think, is the first thing that I want to mention there. And actually, in modern applications, and we're talking about orchestration capabilities that we get from technologies like Kubernetes, for example, they give us a really good starting point. So within Kubernetes, there is something called the pod security standard. And the pod security standard's got a number of levels. So privileged is one level, for example, baseline, and then also restricted. In zero trust, you can ignore all of them, but restricted. Now, it's a little bit technical in terms of the answers, but it's actually a really important point. And I have a nice mnemonic to remember this by. But the first things first, when you look at restricted, and what does that mean? So it means that, first of all of your deployments will be required to be introspected via an admission controller. Okay, these things can be free, or you can have a paid version. So Aqua as an enforcer, Kube enforcer, and that acts as an admission controller, or you can use OPA. There's lots of options out there for this. But what the admission controller does is it introspects the post request. So if you do kubectl apply and then apply the deployment file, then that will be introspected and it will be looking for policy violations. Now, the requirements for restricted that meet all of the principles of zero trust are quite stringent. So, for example, you're required to use to turn on SecOmp. Now, SecOmp is all about system calls. It's all about minimizing the system calls that your application will or will not use. So, for example, if you run the ls command in Linux, out of the box, that uses around 200 system calls. You turn on SecOmp and it's down to 11, open, close, print to the screen, etc. So you want to ensure that you're meeting principles like least privilege within zero trust to ensure that you're only using the system calls that you need. Secondly, it's going to enforce things like a UID. So in a restricted mode for zero trust, you want a UID greater to or equal than 1000, meaning that it's a non-privileged user. So even if the code itself can't be trusted, If there's no access to the code or the user has no permissions to be able to do anything with that code, then that gives you a better chance of being able to defend against that attack in production. And then there are other configurations as well, for example, read-only root file systems. So it enforces that. It enforces that you drop all Linux capabilities. And then there are other principles as well, like the minimalism in container deployment. So this is the idea that you remove all unnecessary capabilities, say curl, for example, which could be used as mechanism to download a payload from a command and control server, for example. If you remove that capability, then there's no way to do that, or no easy way to do that. So being able to remove all of those capabilities, be able to reduce the permissions down to the absolute minimum, and allow no access to the underlying code that's being protected in this container configuration is the way that you want to be able to architect towards zero trust. So just to reiterate that, because that was quite a long answer, but you want to look at something like the pod security standard in restricted mode, and then enable all of those configuration items via a policy and then enforce. And this will ensure, and you'd be surprised that how many of your applications will operate just the same, but there will be no underlying access, or it won't be over permissive access to the underlying code that's being carried by that container.
Thank you for leading us with that question. Is there any other comments from the other panelists? Probably have time for a couple more. Adam, we haven't heard from you yet. Where does your head go when you hear this?
I could probably easily just say whatever Philip said, right? Because he answered it perfectly. But my mind typically kind of goes probably to maybe a more simpler explanation. It's more of a role-based access control. Having, like you said, kind of defining the role specifically to what it needs to be. Not just allowing by design, but allowing, as an exception. Right, so that's kind of like the idea we kind of think about it. And then, we talked, you mentioned it, but containerization of the segmentation of the containers, right? So if you can actually segment them, kind of provide more strategy, really isolate them, that micro segmentation strategy, which is really key to zero trust, it goes in line with that least privilege mindset to prevent that lateral movement, to prevent the adversary, if they were to have access to code, or you were to have that malicious code that's in there, from being able to propagate throughout, which is part of what we see a lot of times in environments that don't implement either proper role-based access or microsegmentation. Once access is obtained, you can never fully prevent unauthorized access, but you can limit the exposure once it's been obtained. So having the mindset of role-based, containerization, and just kind of utilizing meshes to isolate and segment what an adversary could do. So assume a code can be compromised. And if it's compromised, look at what are the secondary and tertiary effects of that, right? And if you can go further down the rabbit hole and think as an adversary and look at what can I do after I've compromised it, now you can start looking at how to control that and isolate it from further spreading.
Thank you, Adam. And Edmund, do you want to weigh in on this as well? Or we also have an audience question specifically.
Yeah, I have. I just wanted to add a little bit of a government flavor to it. So during our reviews at the DoD level with the DoD ZPFMO group, there is this construct, right, of activities for which a program, a project, environment, infrastructure, whatever we want to call it, right, that must align with the zero trust policies under the DoD guidance. And they call them activities, right, zero trust activities. There is this construct of target activities, which is about 91 of them. And there is the advanced 61. So in a cohesion in total, we're looking at about 152 zero trust activities. And to align how these activities are applicable to some of these platforms, environments, products, applications, any flavor for that matter, these products need to align with these expectations, right? So the requirement from DoD is that by FY27, we need to be in line with the DoD ZTA, activities requirement, which is, as I mentioned earlier, right, the target for, at the minimum, to be compliant with the policies, 91 of these zero trust activities. Some of you folks have not seen what some of these activities are. Just to note, for example, 1.7.1 talks about deny user by default rules, right? Or enterprise identity of lifecycle management, or having a monitoring capability, which is 163, I think, for all of the user, right? From a zero trust perspective, everything is considered a node or an edge device, right? Even from a user perspective, right? You need to have that relationship from the moment a user accesses some trusted resource to the moment that connectivity to that resource is then terminated, and how you terminate, how do you get rid of non-persistent accounts. So there is a lot of work on our side from a government perspective. So building that relationships with the partners from the industry, when we develop these solutions, right, we need to keep that in mind, that for us to align with DoD requirements, we need to look at these zero trust activities that DoD has published for.
Thank you, Edmund. So unless we have any other comments, flag me down if we do. I'm going to ask for our first poll question to please come on screen. For our audience, again, this is for you to receive your CPE credit. So I want to respond to this. To what extent is your agency adopting immutable infrastructure practices to enhance cyber resilience in containerized environments? So please take a moment to respond to that. And for our panelists, moving right along to our third question, Martin, if we could start with you, I'd love to ask, how can agencies harden their container workloads against vulnerabilities and ensure configurations are validated against strict security policies before deployment?
Boy, what a great question. Thank you so much. So I think one of the things that CISA has done to make this easier, working obviously across civilian government and with industry, is to refine, and we actually issued the second version of the Zero Trust maturity model. It's available on the CISA website. It's been actually, I guess it's about to celebrate its 1-year birthday. And within that maturity model, it talks about the different ways to make determinations about the application of all the different kinds of protections we've been talking about based on the risks that you're trying to prevent and the impacts that you're concerned with. Obviously, one size doesn't fit all. And so we want to make sure that we don't just apply the exact same structure to every single workload, but it gives you an opportunity for flexibility, but without making, without omitting the kinds of controls that you want to have in place. So I think the first part is, please, check out this really important work that was put together by my good colleagues, Sean Connolly and John Sims. And then I think, more broadly, I think, folks have to recognize and understand that this is something that's expected from the vendor side. When you're trying to sell products to agencies, understand that they're going to want answers to questions that provide assurance that they're acquiring solutions that have these kinds of protections in place, and they're going to want evidence of that as well. And then, for those of us that are still maintaining our own infrastructure, we're going to be able to demonstrate these capabilities. So I think it's a long roundabout answer, but there's a lot of resources out there, and there's a lot of guidance on how to do this. And hopefully your agencies are getting the right resources in order to implement these capabilities. I know the CDM program has absolutely been uplifted to assist agencies and to adapt the control sets that they've been provided through that program. But hopefully also agencies are aware, and we're looking into our budgets to make sure that we augment that with all the things that we need in order to meet our obligations.
Thank you, Martin. Adam, would you like to respond to that question as well?
Sure, kind of picking up right where I left off with a CDM, having a process in place to continuously scan and monitor the containers, checking for misconfigurations, making sure they're adhering to strict security standards. That's kind of what you need to continuously do. And that's what the CDM process is going to play. It's a continuous monitoring, a continuous effort. A lot of times when we're doing evaluations of containers or your evaluations of code, it's a snapshot in time. It's as it's built. So if an organization does not have a process in place to continuously check as that code is updated, as perhaps maybe new code are released on, say, GitHub or something like that, monitoring for that, checking vulnerabilities, having a process, a pipeline in place that whenever something's going to get deployed, you're looking at it holistically as well, right? You don't want to just look at it piece by piece. How does it affect everything all together? Making sure the dependencies are also kept in line to avoid any mistakes as well. So that's kind of what you want to see for hardened containers. You want to minimize the attack surface, right? Your code needs to be in place to perform its function. You don't want excessive code, right? But you need just enough for it to function. If it shouldn't be there, take it out, right? The more you have, the more you need to fix, the more you need to monitor, the more you need to patch, the more chances are that some mistake is made. And while that's where we do want to get to, where perhaps AI can help us with that, but until organizations, especially in the government agency, starts really adopting these AI models to do a lot of this automated validation of the code, sometimes we're having to use certain tools and still manual checks with the tools that can lead to mistakes. So minimizing the attack surface is key to really helping to improve the container security as a whole.
Absolutely. Thank you. Trevor, yes.
Yeah, I love this question. Thank you for asking it. To complement Martin and Philip's points on not just policies in place at the technical level and system level, but also the wonderful guidance out there that our colleagues have put together. An example I'd like to give is something fantastic that Platform One did, and that is layering container images. Containers are very good and are meant to be layered. And what I mean by this is, this is a zero trust motto is no trust, no problem. And I hold that very closely to what I call YOLO internet polls, or you only live once, that acronym. And that pulling from the internet does scare me. So what Platform One does very well at is pulling from its trusted container or registries rather. And then it pulls down a base image. And what it does in there is further layers it down, and it adds its DoD specific CAs, specific packages for common network services, some other potentially required things by organizational policy. And then it further layers down an image. So say I have a Java application and I need Java 18. I know that I can pull down an image and trust that it's layered multiple times for Java 18. But Philip may have a .NET 6 application, and he can do the same thing and have that layer of trust pulling down so that he can develop and deploy his .NET 6 application. And then something else that I don't actually see spoken about often is sign the container images. Containers are simply just a packaging format, and like all other software, it does need to be cryptographically validated before use. And so thanks for letting me share that.
Of course, thank you. Edmund, go ahead.
Yeah, I just wanted to emphasize Trevor's, which is spot on, right? It's this necessity for auditability, meaning that great, you build a container image and you deployed it, as a container, but then how do you connect what's in production versus what was developed, right? With the raise process, one of our security gates, in order for us to leverage automation for risk assessment, one of our security gates is exactly what Trevor said, is that in order for this container application now to deploy in an operational environment, it must be signed to enable that zero trust principle, as in that if it was developed by who said it was developed and what's operating in production is exactly that signed container for which was produced by that given target, to that deployed target audience. Over.
Thank you. And Phil, go ahead.
Yeah, I'm just going to add what's just been said. It's a really important point. In fact, one of the first things I do when I do threat assessments is look for the signing of images. And you won't be shocked to know that I almost never see it, almost never. And so one of the second points I wanted to make there, that once you've signed it, then you have to have another job that validates the signature. Okay, so it's not enough just to sign it, you have to validate the signature. Now, the benefit as well is that you can then use that hash as a label or a tag on the container itself. So when you push the image to your production ECR, you should, if it's immutable, you'll be give that hash, that very same hash can then be used as a tag on the image, so that when you pull the image as part of your CI/CD process, you're going to be pulling it based on that tag, and then you can track and trace that image with that unique ID throughout its entire lifecycle. So it's more than just validating and gaining trust that the image is the image that you built. You can also then use that as a technique as part of your continuous monitoring and validation in production, which is very much a zero trust principle.
Thank you. Okay, so we are going to call for our second poll question before we jump into our next question. So if we could get the poll up on the screen. There we go. For our audience, this is your poll. Your second poll: which aspect of operationalizing zero trust poses the most significant challenge for your agency? So please take a moment to respond to that. And then moving right along to my next question, I'd love to start with Edmund on this one, and then we can hear from a few other panelists. Edmund, in the pursuit of a zero trust architecture, what role does immutable infrastructure play in enhancing the security of containerized environments? And along with that, how can agencies implement it to prevent drift and unauthorized changes?
Oh, that's a good question. And specifically when it comes to the Department of Navy, right? We got airplanes, we got ships, afloat as in weapon systems. We got, like mobile units, like MRAPs and garrisons. And when it comes to how do you make your infrastructure immutable, the challenge we have right now is that collectively from a DoD level perspective, we need to start thinking about a reference architecture as to what constitutes immutable infrastructure on these multi-dynamic ecosystems of different environments, right? And a float environment for a ship is different than a shore environment. On the shore environment, you also have something like a business, enterprise applications. You also have, information environments. You have, weapon systems that are both on the ship and the shore perspective. So it is important to have immutable infrastructure in context that if there is something bad in production, you should be able to provision a new infrastructure, right? With as we talked about, as Trevor mentioned earlier, right? A signed immutable infrastructure for which can be deployed and ensure some level of security is associated with it. And whatever threat actor had access to your infrastructure in an operational environment, you have a high level of confidence that what you're deploying right now, any vulnerabilities or any issues that were associated with your previous deployment, right now it's a clean environment for which in support to that operational mission. But again, it's really challenging because from let's say using playbooks or Terraform or infrastructure as code to deploy these environments, we have this dynamic ecosystem, and we also have to start thinking about the sizing component of it, and the connectivity perspective. And I'll give an example. Within the last couple of years, we had to deploy a Red Hat OpenShift infrastructure, right? From an infrastructure as code using the Red Hat OpenShift platform as a service solution. Well, if you deploy that into a high performance network, if I may, the whole thing would complete in 45 minutes. We wanted to make sure that it was signed, it was the right configuration model and everything. Then we go into like a DDIL environment, which is the disconnected, environments, or in a low bandwidth environment, and the whole freaking thing would fall apart because we would go from 6 megabyte downstream into our execution model to like 25 kilobytes, and now the containers that were like 2 gigabyte, some of these large containers trying to pull over the network, it would fail. So the whole process failed. So again, I'm bringing this up as an example to emphasize the necessity that even though immutability is important, and ensuring, a more rigorous process for security in an operational environment. We also have to keep in mind that sometime when we create this infrastructure as code models, we need to keep in mind the connectivity, the networking challenges, the access control associated in different levels and different environments. But again, there are different conversations that can take place within the immutability of an infrastructure. But as a goal, it's definitely what we are pushing towards, to ensure that we successfully have and just-in-time deployment of this infrastructure when someone identifies that there is some vulnerability or threat actor within your existing infrastructure. Over here.
Thank you, Edmund. Phil, go ahead.
Yeah, I think I want to give some guidance from the field here on this one, particularly in the private sector. So we've been doing this for a long time in the private sector, specifically in banking, mostly because we don't want to forward fix. Okay, no imperative changes, so no changes in production. Everything needs to be redeployed, subject to scrutiny, pipelines, policy as code. So even minor changes should be subject to that level of scrutiny, specifically in zero trust. So we've had to figure out how to do this. Now, along comes the cloud, microservices, where we have replicas, we can do rolling upgrades. It gives us the ability for the first time to be able to, use load balancers to point to live working resources whilst we upgrade small single executable binaries. I think what Edmund's talking about there is larger infrastructure with complex monolithic applications, where actually having an engineer to be able to get access to them in live is part and parcel of operating in that environment. The trouble with that is that you can never really meet zero trust in that environment. So one of the single biggest challenges I fear for the government, specifically, for the DoD and in the environments that they work in, those hostile environments, is how do you build that with the current, mothball infrastructure? The answer is that you've got to move to digital, to the cloud, to microservices. All of the advantages that come with that will enable us to be able to get to zero trust cleaner and much quicker. But it's a complicated answer and one that I fear has not been solved yet.
Thank you, Phil. And Trevor, go ahead.
Yeah, I'd really like to touch a little bit deeper into the challenges Edmund brought up. Some of these Kubernetes-based distributions are intentionally resource greedy. We're not going to be able to use our older hardware, like spinning Rust disks, and expect high performance or even a level of performance that's just okay out of these types of technologies. Like, we need to have the ability to have fast read writes, fast caching, and fast distribution of these environments. My experience with the type of environment Edmund touched upon is those day zero installation operations, super easy. When we start implementing and trying to communicate in networks that are intentionally disadvantaged by some sort of design, we kind of remind ourselves, oh, maybe we didn't think about that. These 3 GB container images, we need to lower down, maybe layer these containers further, make them smaller so that these environments have a sizable execution to be able to pull and mesh and deploy and handle all these different applications. But also, because they're disconnected, have them in a state where they can be self-healing, self-correcting, and whenever they do connect back, they're able to pick up where they left off, but also maintain independence from its managing infrastructure.
So it's really it's following the principles of Linux, right? Which is, do one thing and do it well, and then store that one thing in a container and run that as a microservice in a container and connect them via a network, and that really does work, right? And that's how you create immutability. I think the challenge that maybe even some of us on here can't conceive is how do you refactor, that monolithic application or those bloated resources that you talk about into those single microservices in the timescales, which is just 2 short years away from being able to achieve that. It really is a challenge and needs to be, we need more think tanks to discuss this through, because I think right now, if you've got a clean, new digital cloud application built with modern programming languages, it's easily achievable. And as you say, it's super easy, but it's those old applications that worry me.
Philip, it brings me so much joy that you brought up the principle of Linux. Do one thing and do it well.
Yeah.
It's my favorite part of today. Kirsten, what I like to think about for immutable infrastructure is these are sort of designed secure by default, and I do believe that the operating system of the future is immutable. And I'll close it right there.
Edmund, I see your hand up. Go for it.
Yeah, I just wanted to kind of high five Philip on that, right? Is that self-healing is really important, but a lot of times, this is not a negative on the industry by any means, right? But we have some of these tools that the industry develops, which is great, right? We need the help. But a lot of times I feel that there is a lack of, to Philip's comment, to look at outside the box thinking. From a ship perspective, I also have to think if my server vibrates enough, because there is vibration, right? Now there is some kind of disruption in even a signal if it's being over the Wi-Fi, or if it's a cable being rattled and the networking. So there's so many different aspects that when a lot of these architectures for the new tools are being designed and developed, I'm encouraging the industry to start testing some of those capabilities with low bandwidth, right? Like if I'm doing infrastructure as code for deploying a Kubernetes, orchestrator and a bunch of different tools to build my entire ecosystem for supporting the mission, can I deploy this entire infrastructure as code, capability into a low bandwidth or over the air, pulling these images? So, kind of put another angle versus having a 1 gigabyte, Ethernet plugged into my server and I don't have a problem with my internet, right? So again, it's a conversation, again, to Philip's comment, that from a think tank perspective, we need to start thinking if there is support to the DoD, it's not just about the zero trust and the immutable infrastructure. I don't need immutable infrastructure if I have a active hack, in my production system, and I need somebody to actually just block that port right there, right then, because I'm hot in the mission and I can reach to the shore. So again, these are some of the conversations that we collectively need to start thinking about. Over.
Yes, thank you. Okay, so we probably have time for one more question before we end with takeaways. So Adam, I'd love to hear from you on this one, which is that given some vulnerabilities may not manifest until runtime, what are the most effective strategies for runtime protection and policy enforcement to maintain a secure containerized environment?
Good question. Some of the effective strategies for doing the kind of runtime involve more behavioral monitoring, for detecting, checking for unusual activity. It falls really into it's kind of a whole line of heuristics, understanding what should be there, what isn't there. Knowing it's kind of one of those unfortunates where you may not know what's bad, you just know what's not good. So then you have to do a little more investigation into that. It kind of delve into that mind and employing kind of a real-time security tools to block something actively that's happening, isolating containers. Automation is key with the runtime, right? You can't rely on a human to deal with a runtime attack or runtime protection. You want to have some automation in place, some tools in place to quarantine and isolate and then notify. That way it can be dealt with at a more reasonable pace rather than trying to be reactive as an environment continuously gets compromised or until you can do some investigation. That's kind of what you kind of really need to do. And just make sure your policies are updated, establishing kind of a feedback loop with the team, making sure that as things get detected, as things are found out, you reach back with the security team and say, hey, what can we do to make this better? We found this, can we block this in the future? what should we have done differently? Having that communication between the developers and the security team really help prevent future threats like that.
Thank you. Phil, I think I saw your hand up next. Go ahead.
Yeah, I think runtime is super important. It's the last bastion, right? It's the last line of defense. If all of your other layers of controls fail, yeah, it's just a matter of persistence sometimes. And even with every conceivable control, you've also got the insider threat, right? So there is always a way that someone will find the way, and when they do, then you need to ensure that you have exactly what Edam was saying there, that you must have policies, you must have behavioral detection. You must be able to have behavioral detection that's automated, so it needs to be able to identify what an attack vector looks like. So use things like MITRE ATT&CK when you're looking at architecting your environments to see what a typical attack looks like, right? In most cases, the attacker needs access. They need to be able to get the payload onto your system, and they need to be able to execute a binary. At any one of those points, you need to have a layer of control that would help you to defend against that. But in the absence of absolutely nothing else, you need the ability to be able to defend against drift prevention. So that would be a binary that executes that wasn't part of the original image that you deployed. So you need a way to identify that, and then a way to be able to block that, because that's how you stop a 0-day. So that's going one level beyond behavioral detection. That's looking for code execution that wasn't there by design.
Mm-hmm. Trevor, go ahead.
Yeah, I really enjoy that point, Philip. I think that sets up well for what I want to jump into. And I do believe the protection of runtime begins at the beginning of your SDLC or your CI/CD, right? Do we have the mechanisms in place? It's been mentioned, some sort of behavioral detection, some sort of policies in place, but the security testing that's going to scrutinize the change all along the way throughout the SDL. Are we tackling network isolations that are preventing inter-container network traffic? Are we mixing, something to consider is, are we mixing our workload sensitivities across each other? Is my low application sharing a space with my high application? Should it be that way? Do we have unbound network access across containers? We touched upon untrusted images, unbounded administrative access. And we touched a little bit more on, well, a bit earlier on, do we trust the registries, or do we trust where we're pulling our container images? And insufficient authentications and authorization restrictions can really come back and haunt us.
Thank you. And Edmund, I couldn't tell if your hand was up from the last question or if you wanted to respond.
I'm so sorry. I'll add just very quickly, because I know the time is limited, and I apologize for that. But I just want to emphasize both to Trevor and Philip's comment is that even though from a container perspective, right, and as a developer myself, just 2 days ago, I had defined my network in the layer to be custom, but then somehow when I was trying to reach outside of it, again, having one of those moments as a developer, for like spent 3 hours on it, and I was looking at the problem in my head. In front of my face, and I couldn't figure out what's wrong with it until I involved someone else. And I said, hey, what the heck am I doing wrong? I don't see it, right? So they were able to help me out. I brought that up as an example because even though containers sounds cool, right, when we deploy applications, there is a level of complexity associated. And when you now introduce like an orchestrator like Kubernetes, and then you deploy it into a disconnected environment, and then you apply upgrades, there is backward compatibility. So there is a lot of aspects that need to be considered, through the process. And there's always a chance that humans do errors, not intentionally, but unintentionally. So that's why leveraging things like immutable, infrastructure and configuration scripts that can be validated prior to deployment, it will help us reach better results and outcomes at the end.
Absolutely, thank you. And time for one more comment. Martin, would you like to weigh in?
Well, I mean, those are great answers. Nothing on this one, but I guess, just sort of like a general thought is, we all, my day job at CISA is maintaining all of our enterprise technology requirements and working with all the programs. And there's a mission impact, right, to all of these different security capabilities. Obviously, we need to deploy, but we also have to think about how they impact our legacy applications. And oftentimes in these conversations with vendors and with technology developers, I hear like, well, the government doesn't articulate their requirements very well, and we don't know what we want. And listening to the speakers today, I think we actually articulate them pretty well, and we know exactly what we want. And I think one of the things that I would encourage vendors to do is think about ways to deliver these capabilities to us in flexible ways where they can be applied based on the variances across the infrastructure that we've been referring to. And I think it's really interesting to hear the different ways that folks like to deploy technology and the impacts potentially those security controls would have, but also the kinds of advantages that they're trying to achieve. So in general, I think this is just like a really, really interesting conversation. I hope folks are listening.
Yeah, absolutely. Thank you for that. Okay, we are going to post our third and final poll question for our audience. How is your agency incorporating security tooling and practices to support a shift-left approach in the development lifecycle for federal applications? So please be sure to respond to that. And there's one more poll at the very end, so please stick around. That being said, we are coming to the end of our hour here, and I would love to wrap up with a round of key takeaways from this discussion. So each of you just one takeaway each, and you have about 2 minutes to respond. So Trevor, do you mind if we start with you on that?
Sure. Could you remind me what the question was, or was this the overall takeaways?
Yes, your key takeaway from today's discussion, what you think is the most important concept or idea that you thought about throughout this last hour here.
Oh, sure. Sorry, I was reading the Q&A poll and back to responding. I think that there is a good deal to take away from this. Everybody has shared just a wealth of knowledge and a great deal of things to consider from what does our architecture look like? Are we not just shifting left, but are we designing secure by default principles, but while also meeting our zero trust maturity models as well? And just policies, like it always comes back to not just the technical system policies, but also the organizational administrative policies in place. My takeaway is these are cool and these are fun, but not having the support commercially or internally can come back to haunt us. We may be building and designing really cool things, but we may not be always spotting the weaknesses that we create. And so having those types of assessments, having those different perspectives as part of the planning and design phases are just as important, if not crucial.
Yeah, wonderful. Thank you. Adam, what is your key takeaway from the discussion?
One of my key takeaways actually is going to fall back to the very beginning, which was sign your stuff, sign the containers, right? That way things are the way they were designed to be. But one of the things I was thinking about with that was don't just sign it with any certificate or any code sign certificate. Have something that's trusted in your environment. Third party CA, another CA to design, everybody signing, self-signing certificate kind of defeats that purpose. So you want to, it's deal with my mentality of the zero trust, having a centralized trusting platform and designing, but securely in the beginning. That way you can trust the deployment of your containers. You can trust the deployment of the code, because if you can't trust it from the very beginning, from its development, how can you trust it once in production? So that's kind of one of my key takeaways here.
Thank you for that. Martin, what about you? What's your one key takeaway?
Well, I have two key takeaways. The first is I think Trevor might have suggested a new session for you on assessing your zero trust implementations. But I think generally, just to go back to what I've said a couple of times, particularly with the focus I have on, artificial intelligence risk management, these infrastructures that underlie all of these applications are leveraged in ways that the designers and the maintainers of those infrastructures don't always understand. And so there needs to be a lot of communication with those folks throughout this stack, if you will, of higher applications to ensure that the security controls that are being deployed in this fashion are complementary and not having impacts, but also are meeting the requirements that those particular stakeholders have. So we have these incredibly complex hierarchies and ecosystems within relatively small organizations at this point as a result of this. And so it requires zero trust professionals to be able to have those kinds of conversations really across the entire spectrum.
Well said. Thank you. Edmund, let's hear from you next.
Oh, thank you for that. It's great to meet some of you folks, and I'm hoping that we will continue these conversations going forward. But I have almost like a plea to the industry that, as I mentioned earlier, containers are great, but we also have some challenges when we're trying to develop a container that can deploy on something like Red Hat OpenShift, which requires a specific configuration for the user association to it, versus a traditional Kubernetes. So in order for us to have this holistic view of designing and developing in one place and then deploy across multiple different dynamic environments, i.e. Tactical systems, weapon systems, shore and afloat, as well as edge devices, whatever there may be, like on subs and ships, that at some point I would like us collectively, and I think Philip mentioned that earlier, from the collective of the willing, to have a working group to start thinking about a reference architecture that focuses on the high level definitions of, hey, we talk about OCI compliance and CNCF compliance, but then we have different vendors with different Kubernetes interfaces or configurations that not all containers can deploy the same way across these different Kubernetes orchestrators. So I'm hoping that we collectively come up with this reference architecture to help us, not just from the government perspective, but the industry, to all align those expectations and find a cohesive way for us to work together and share some of our lessons learned. Over.
Thank you. And Philip, we will end with you.
Yeah, okay, so I've got a couple of things. First of all, I need to address that. And then secondly, I'll give you my final kind of overall takeaway. Okay, so in the UK, I used to do AWS migration readiness assessments. And this is where you'd go to a government agency and then determine from all of their application stacks what would be suitable for public cloud and what wouldn't, what needs re-architecting, what needs refactoring, what needs rewriting. So I have a lot of experience in that space, a lot of out-of-the-box thinking. And sometimes when you look at zero trust, and I mentioned, so I started zero trust in 2017 for a large UK bank. And we thought about this a lot. And the part of the problem is, if you look at the individual parts, and this really concerned me, Edmund, earlier on in the presentation today, when you talked about these 90-something tasks. That really concerns me, because I think if you try and meet every single one of them, you're just going to be chasing errors. And I worry about that a lot. What you need to do is come up with an overall zero trust strategy. So to get down to that minutiae level would be virtually impossible. Actually, it would be impossible. It's just too complex, too much. And you'll fix it in one place and you'll break it somewhere else. I absolutely guarantee it. What we need to do is we need to come up with overarching capabilities that, as a generalism, meet the principles of zero trust. And where you can't meet zero trust, explicitly meet it, there has to be mitigation that can be risk accepted. Otherwise, we're never going to get there. And I think that's the worry for the deadlines, and that's the worry when someone is over-architected what we consider zero trust to be. So that's my real concern there, and I think we have to address that. I definitely want to help with that because I think I can. In terms of a final takeaway, I wanted to bring up the whole. So so for example, when we consider, you have to consider all of the components within an application, not just even your own code. In modern development, we assemble code. We use third-party packages. We have centers of excellence. We reuse packages from colleagues and other teams. We don't always understand the provenance. And we don't always use all of the packages, right? We see this in our data. A significant portion of packages that get imported, they remain on disk, but they never get loaded into memory. Those functions are seldom called, and yet those vulnerabilities are carried through into production, even though they're inert and inactive. If something happens to the code, or a call is, or that function is called, and that considerable vulnerability is now live in your production environment that you didn't know about when you deployed it, it's critical that we apply continuous monitoring and validation in production. And we have strategies like the ability to rotate workloads on a regular basis. In banking, I got this down to every day. We rotated all of our clusters every single day. And we started off by only rotating once every 9 months, which coincided with the Kubernetes upgrade, every third upgrade. So, we have to get into those levels of practices. But before we can get to that level, I need to go back to that first point I made, is that we have to address some of those concerns because they are actually concerning.
Yes. Well, thank you so much for sharing that. And I want to thank our partners at Aqua Security for making today possible. This is the last poll question. Would you like to receive your CP credits? So be sure to respond to that. I want to thank everyone at home for joining us, and we hope to see you all at the next event. Thank you, panelists, so much for the insight. It's been such a pleasure.
Thank you for having us.
Thank you, everyone.
Have a great rest of your week. Bye.